Welcome back. We talked about your favorite science story of the year. We're not done yet. The national science correspondent, Bob McDonald's been filling us in. And Bob, time to hand out a prize.
Yeah, the big one, the Nobel Prize in Physics.
This year's prize is about something very small that makes all the difference.
Well, it was no surprise, really, that Peter Higgs, who proposed the Higgs boson, got the prize. And it's funny, he's a very shy man. And as soon as it was announced that he won, he took a holiday and just left the country. He wouldn't talk to the media, wouldn't talk to anyone. But it was because last year, the Large Hadron Collider that you've been inside, you lucky fellow, actually discovered that the Higgs really does exist. And this was a big discovery because the Higgs boson is one of those particles that doesn't fit out there. They have all these other particles. You got protons and electrons and neutrons and all those things, and they can model them up. But then there's this Higgs out there all by itself, and they hadn't found it. And
they thought it existed.
They predicted it. That's what Higgs did. He said, you need this to put together what they call the standard model. So the standard model tries to describe the Big Bang. How did the universe come to be? How did we get to be here? And if you think about it, the Big Bang was nothing but energy. The universe was so hot, and it was so dense that it was all energy. And if you think about taking energy and just making it a whole lot bigger, all you get is energy. How did it get lumpy? How did we get here? Because we're not energetic. You and I are made of solid stuff, and we're pretty cold.
You seem pretty energetic right now.
Yeah, not compared to the Big Bang. So Higgs said there had to be something to go from energy to mass, to things that are cold and dark and slow. And it was his particle and a field that goes with it called the Higgs field that allowed energy to transform into matter early on. And so it needed this field and this particle, but it wasn't until last year that they actually found it. So that's why they gave it. So they know that the standard model of how we think the universe came to be is right. So now they go on, they think, well, are there other Higgs? Is there a whole other level of physics of this? And the Large Hadron Collider, right now, they've shut it down, and it's not because it's broke, it's because they're fixing it to make it even more powerful. And it's going to come back at twice the power it had before, so who knows what that's going to lead to. I'm really excited about it, actually.
So let's move on. Discovery Magazine ranked the Mars Curiosity rover as Science Story of the Year.
And I would agree with that, almost number one, but it's good. For just about a year, and just recently they announced the sort of culmination of all of its discovery. It's been sampling the soil, it's been digging into rocks, and trying to find out what Mars is really made of. And what they found out is that if Curiosity had landed in that same spot 3.5 billion years ago, it would have done a splashdown. It would have been a submarine. It landed in an area that used to be a lake. So 3.5 billion years ago, there were two blue planets in our solar system, Earth and Mars. You could have gone swimming there. And something happened to Mars. It went from being a warm, wet world into a cold, dry desert that it is now. Talk about climate change. It went into an ice age, but it didn't come back. The Earth has been into ice ages many times and come back out of them. Mars did not. That's why we go there. So the big question now is, when it was wet back then, that was the same time that life was just getting a foothold here on Earth. So did it happen there too? We don't know that. That's why we got to keep looking. So it's been a very interesting year, and Curiosity still has a lot of work to do, probably for the next 5 years. So there's more to come.
When I was a kid, we talked all about Mars and Martians.
Yep.
Do you think this is re-engaged interest in that planet?
I hope so, because our original thought about Mars was that it had canals. We thought about it as a water planet, but also as a desert planet, and they might come here and steal our water, War of the Worlds. Now we're invading Mars. It's the other way around.
Now, we said goodbye to another man-made project in 2013.
Voyager 2, all the way out of the solar system.
3, 2, 1.
I was actually at this launch in 1977 when my hair was black and down to my shoulders. And Voyager was one of the greatest voyages of discovery of the whole space program. It did a grand tour of our solar system. It went by Jupiter, Saturn, Uranus, and Neptune. And it took 12 years to do that. And each time it did, those big planets gave it a gravitational boost, and they kicked it right out of our solar system. And now Voyager, still running, is in interstellar space. And it's the first object to do that, to leave the influence of the sun and be among the stars of the Milky Way. And it's now out there measuring measuring magnetic fields and plasmas and telling us what it's like between the
Still
stars.
able to send all the
Yep.
material back.
And it's sending back less power than a 100-watt light bulb. And you think about that, when the thing is farther away than Pluto, way out beyond Pluto now, it's just remarkable. And it's carrying a message. It has a gold record on it because when it was launched, we didn't have digital technology. It's got a gold record and a needle to play it.
A needle to play it.
A needle to play it and instructions on how to play it, how fast. And it's got photographs and music and a message from Earth in case anybody out there finds it. It could live to up to 100 million years in space.
Speaking of age, in 1977, I was 1 when you were at that launch. 1 year old. Anyway,
won't tell you how
Bob,
old I
your
was.
favorite for last. Let me guess. Canadian astronaut?
Our Canadian astronaut, Chris Hadfield. What can I say?
Thank you very much. With that, Chris, it's time for me to offer you command of the International Space Station.
Thank you, Kevin. With great humility and pleasure, I accept command of the International Space Station. Thank you, sir.
There you go. Good boy.
Commander of the International Space Station, our Canadian Chris Hadfield, first to ever do that. And he not only did all these experiments in space, he did wonderful videos that he sent to the ground of how do you cry in space, how do you wring out a towel, how do you have breakfast, how do you make a peanut butter sandwich, how do you go to sleep. And he brought space to life. He brought it down to Earth, and that was his intention right from the beginning. So he's a remarkable role model for achieving his childhood dream of flying in space. He did it 3 times. He was the first Canadian to do a spacewalk. He mounted the Canadarm on Space Station. Then he became the commander. Now he's got a book out that tells his story. He's a really remarkable guy, and I think we should all be proud of him.
Just worldwide attention, too. Do you think it's the end of the era?
No, I don't. Chris has had many eras in his life. He's been a test pilot, an astronaut. Now he's going to become an adjunct professor at the University of Waterloo, and I wouldn't be surprised if we see him flying interesting machines in the future.
All right. Bob, thanks very much. That's a great top 10 list.
My pleasure.
And Happy New Year.
Same to you.
We're going to be back in just a